everyone. I've got a difficult slot, the famous Friday afternoon. So I want to talk about this new transformation that's happening in the world of digital intelligence. Now, drones, AR, reality capture, they're not only reshaping the world of engineering, but it's redefining how we perceive risk, how we manage risk, how we design and plan. It's not an evolution in the professional world. It's really, and I honestly mean it, it's a new era. It's a complete new way of doing things, something that hasn't existed before, and it's shaping a new industry in itself. So what I want to talk about is what lies beyond BIM. A bit of a challenging topic today, but there's a lot more to building information than Revit and 3D models and going from point clouds into the design environment. And I want to explore what the full sphere of reality capture looks like. So when we get a project, just for reference, taking a little step back, I'm a structural engineer. We work on digital analytics and building solutions to really reinvent what engineers do, what project managers and asset owners can do with digital data. So when we get a project, there are 4 core areas. Number 1 is understanding its needs from a technical point of view. Number 2 is how do we now go to site? What tools do we use? So we've got a full drone team. We are a registered drone company. We've got laser scanners, manned aircraft. And the reason why you have to have a diverse assortment of tools is one tool doesn't do everything. The guys that fly drones, they force the drones onto the clients. The LiDAR guys, they force the LiDAR onto the clients. Different tools are good at different things. Now, very, very important, and what the meat of this is all about is what do we do with that data? What do we do with that heavy 3D information or point clouds or meshes, and how do we deliver that back to a client, to an asset owner who may not be technical, and help them understand what we're talking about? Now, in the world of digital engineering, there are 3 pillars, and we've discussed many of them today. Firstly, as-built, digitization, Scan-to-BIM. We call it the foundational science because you need to know how to digitize effectively and accurately before you move on. Now, we have another vertical, which is the world of digital twins, or digital replicas, more accurately. And that is creating a super accurate version of what you have on site. And I'll go into what that looks like. And lastly, the world of GIS, topographical mapping, planning, measuring, monitoring. Now, what happens on most big projects is all 3 of these live together and talk to one another. That is true digital immersion. So starting off with some tools we use to capture this information, drones are really, really powerful. We said it before, but drones not only fly outside of buildings. The modern drones that we use fly underground. They fly inside of structures. They fly in building collapses. That's that one on the bottom left there. And it opens up a new world of access to information. Now, the second component is LiDAR. Now, what do drones and LiDAR have in common, or what's different? Drones are really good at texture. They're good at seeing what the camera lens can see, but they don't do precision. Laser scanners, LiDAR scanners, they are good for precision, metal, trusses, fine detail, machinery, warehousing, and you have to know when to use which option. Now, the most important question, we get a phone call every day that says, can you scan my site? How much? And the question is, take a step back, because what is your level of detail requirement? The number 1 question a scanning company needs is, what are you trying to achieve? Do you want a layout, a generic layout, maybe for an architectural design, or do you want a fabrication drawing where you need nuts and bolts? And it changes the way you approach the data capture. It also changes the way and the level that you model. It's a complete different element versus the 2 different technologies. Now, very quickly, I think a lot of those in the room are familiar with it, but what is level of detail modeling, level of development? This is LOD 100. It's a very basic conceptual layout. LOD 200, you're putting in a little bit more detail. You don't have exact member sizing, but you've got pretty much what it looks like. LOD 300, that's the conventional digital format that engineers work with, that architects like to work with, accurate member sizing, spacing, and layouts. And then you have coordination, and you have fabrication and as-built when you go into the nuts and the bolts. And it's very important to understand and distinguish between all of them. So what does this look like in practice? I always like to show real case examples. This is a shopping center. It's Bedford Center in Joburg. The client calls us, and every time there's two questions. Can you do a condition audit? And can you give us as-built? We don't have. This was one day on site with a drone and some scanners, and we transform that into a format that an engineer, a planner, a designer can now work with. This puts it into their language. And again, BIM, the beauty of it is it's built up of individual elements. Every single building component is in there. We do industrial, mining, heavy power utilities, so that's an example of piping and machinery, and it could be for coordination, for clash detection. This is bread and butter type of work, and this is the essence of what BIM is about. It allows you to make a lot more accurate decisions. Now, another component to BIM is what's below the surface. Again, we just discussed it. This is GPR scanning, ground penetrating radar, and it's mapping out what you can't see. So you don't hit a fiber line or a power line before you go to site. This is everything under the ground, and it is a very important form of technology. The other side of GPR, which again is a more specialized market, is seeing inside of structures, materials, concrete, looking at the reinforcing layouts. This is a fantastic, powerful tool that we use on a daily basis. And now the last component of reality capture, again, a very niche market and a specialized area where we work oil and gas, or if we're working with dams and the water utilities, is getting below the waterline. And it's, again, another just efficient and powerful format of capturing information that used to be inaccessible, hard to reach, or expensive to get to. So that's the world of ROVs. And that kind of closes the loop on the reality capture tools. Now, starting with what do we do with the data? Surveying is its most basic form. Now, surveying is mapping in 2D. It's an X and a Y. The drone flies in the sky. Sometimes we use laser. And it's looking down on the ground. We call it bird's eye view mapping, but it is very, very important. So this is a simple sped up site. This is how we monitor mines, daily mining operations, being able to give the entire team information of what's on the ground, what's changing day to day, what are the contractors doing, where is the plant and the machinery, how is the site evolving. And with these tools, we work fully in the cloud. We built our own cloud infrastructure that allows us to communicate, to reference, to measure, to annotate, not just in 2D, but in 3D as well. So these point clouds run purely in the cloud. We don't send Dropbox links anymore. We don't send heavy files and all this data that gets lost. Everything gets centralized. Now, inspections is my favorite area, and this is where we look at detail. Surveying, looking from above, you want to see what's on the ground, but when you need to look at the condition of an asset, you need that crisp detail. And here we fly in 3D. So before we force drones or new digital technology onto a client, what's wrong with the old way? When we build a solution, we don't want to build a vitamin. A vitamin is a nice to have. We build painkillers. Because when you build a painkiller, you've got a solution that the client will never turn back from. They will never go back to the old way. So many, many issues with rope access, with ladders, with scaffolding, cherry pickers. It's incredibly difficult, expensive, and slow to inspect. But the biggest issue is reporting. When you're hanging on a rope, you can see half a meter in front of you, which means you take a picture of a crack, you climb down, you take another and another and another, and that's the report. Thousands of isolated images. It lands up on an engineer's desk. We have to figure out, what on earth am I looking at? Where are these defects? I don't even know where to start. You never tell your client that, but that's what goes on in our heads. And then the client says, how much are we in for? What does it cost to repair? That's what we do. And we get it right sometimes, we get it wrong. So we are reinventing the world of inspection technologies. And the way we do that is through digital immersion. So this is an example. It's a precision structure. This is an ultra-detailed digital replica. It's a preheater in Kimberley. It's about 100 meters in height, captured in 6 hours on site. The client went out to tender. All the engineering firms came back and said, how long? 3 weeks, 4 weeks, we need to shut down. We said 6 hours, and they said to me, what are you smoking? I said, I promise you now, I will come in the morning, I'll leave before you close your doors. Now, in that time, we're able to collect data that looks like this. And this gives you that same detail as if you were on a rope, but now you can see the overall picture. You can see exactly what's going on. Every defect referenced, every defect measurable. Now, the beauty is the asset owner sees this too. There's no software involved. They get a link, they open it up, they move it around, and they say, I see what's going on. How much do we need to spend? That's step one. Step two is analytics. Now, what we do with those 3D models is we extract maps, and we run it through our AI, which detects every kind of defect, 98% accuracy, takes all those complex reports and puts them on single, easy-to-read drawings. But not only are they referenced, classified, referencing exactly what's going on, but we're able to quantify. Those 3D models are digital replicas with the exact scale as what's on site. So when we now go for repairs, when we do a BOQ and we give it back to the client, all the guesswork is eliminated. The budgets are set and they will be fixed no matter what. Just to give you an example, on a structure this size or a large structure, a cooling tower, a silo, that's the difference between 10 to 20 million rand in inaccuracies. Now, thermography is another layer. It's a very in-depth layer. A lot of the times I show this, engineers say, well, what about beyond the surface? You're just seeing the outside. Thermal audits changes that, because now what was once on the outside, we can see a little bit of cracking. We can see a company's gone up there. They've done what they call a tap test. They listen if the concrete sounds hollow, but you don't really get a feel for what's going on. Switch to a thermal camera. So we always fly 2 cameras on the drones. You can see inside the surface by the heat that's coming off of it. Fractured material, delamination and spoiling heats up and cools down faster. There's an air void in the surface, and that means you can map out all the internal damages on an asset, and you can predict its lifespan super, super accurately. Now, it's not just applicable on small sites. Large sites work exactly the same. Entire mines, power plants, oil and gas refineries. We do it all across the world in about 10 different countries. And this is the future of the boardroom. We don't sit in a boardroom anymore with these A0 drawings, highlighter and a pen. That's what I used to do. And everyone doesn't know what's going on, and they're fighting about things because there's no clarity. This makes everything crystal clear from the get-go. Everyone is on the same page, and they know what's going on site. And it's a complete new way of thinking. It's a new way of operating, and it's being used by so many different clients around the world. Now, we spoke a little bit about some new technologies as well. One of my favorite is splatting. And splatting is a new world. It's brand new on the market. It's not more, probably a year old or so. And its adoption is still very, very new. But it is changing the entire market. So this is an example. It's one of our power stations of using Gaussian technology. And the speed of capture is the speed of walking. This took 5 minutes on site, and I'll show you what it looks like. So this is a gamified asset experience. This is the new way we're walking through sites. We don't send professionals to site anymore, no architects, no engineers, because it is more accurate doing your inspections and actually seeing what's going on remotely. This, you walk through the site with a scanner, you walk out, and you're done. And you see everything, and you can revisit it.